So today we will learn another lesson which is all about calculating the mean and the variance of a discrete random variable. So our objectives, after going through your learning activity sheets or your module you have with you, your learning activity sheets, so you are expected to first enumerate the steps in calculating the mean and variance of a discrete random variable. Next, you're expected to solve the mean and variance of a discrete random variable, and you are expected to give importance or give the importance of calculating the mean and variance of a discrete random variable. So I know you're all excited to learn the new lesson through the help of this video lesson. So let's get started. Okay, so we have an article here. So think about this. It can also be found in your learning activity sheet. So you have with you your own copy. So let me read the report. The PSA, or the Philippine Statistics Authority, reported that on average, a Filipino consumes a total of 118 and 8100 kilograms of rice annually. So that is per year. This is equivalent to 325 and 5/10 grams of milled rice daily. With a current population of 108 and 6600 million Filipinos, the country's total annual consumption would amount to 12 and 9/10 million metric tons. So imagine if one sack of rice weighs 50 kilograms, then 118 and 81 kilograms would mean more than 2 sacks of rice. So a Filipino in a year consumes more than 2 sacks of rice. That is according to the report. So based on the given situation, we have here the following questions. So what does average mean? Does it mean that every day a person consumes exactly 325 and 5/10 grams of milled rice? How is the rice consumption by different persons vary from each other? So if you know the answers to these questions, so I guess you do not need to learn this lesson. But if you do not know the answers yet, you have to stay focused and listen very carefully, because this lesson will help you answer this question and understand the report on this certain situation. So let's have here more examples which can also be found in your learning activity sheets. Okay, so we have here example number 1. Your friend Joe likes to roll a die. As usual, the probability of getting a 1 is the same as the other number in the die. So we have 6 possible outcomes. You already know that. We have 1 spot, 2 spots, 3, 4, 5, up to 6 spots. So they have the same probability, right? So in the previous activity, we have illustrated the mean for this experiment. So in this example, we need to solve or to calculate the mean of our random variable. So step 1. First, you're going to construct it means you're going to create a probability distribution for the random variable x representing the number that would appear. So here it is. We have here a table with 2 columns. So the first column, you are going to label it the name of your random variable. So we have here in our example the number of spots. So that is our random variable x. And we also in the second column your probability for p of x. So we have here under the column of random variable x, we have here the possible outcomes. So we have there from 1, 2, 3, 4, 5, and 6. So we have 6 possible outcomes. So you also notice that each outcome has the same probability. So the probability that the number of spots that would appear when you roll a die is 1 is 1/6. You already know why 1/6. For 2, 1/6, and the 3, 4, 5, 6, they have the same probabilities. And if we're going to examine its properties, we can say that this is a probability distribution. So this is the step 1. Next is step 2 in calculating the mean of a discrete random variable. We're going to multiply the value of the random variable x by the corresponding probability. So how? So you have there the number or the random variable, the probability, and we're going to add another column for the next step, which is random for x times p of x. So x is your random variable and p of x is your probability. We're going to multiply the two. How? So simple as this. We are going to multiply x, sample 1, multiplied by its probability, which is 1/6. So 1 times 1/6 is equal to 1/6. So recall the rules on how to multiply fractions. Okay? So I know you already mastered this because you're already in the senior high school. Another one, and the second is we're going to multiply 2 by 1/6. That is equal to 2/6 because 2 times 1 is 2 and we we have here an imaginary denominator which is 1. So 1 times 6 is 6. So we have 2/6. The same procedure will follow. 3 times 1/6 is equal to 3/6. 4 times 1/6 is equal to 4/6. 5 times 1/6 is 5/6. And 6 times 1/6 is equal to 6/6. So that is the step 2. Multiply x by p of x. Okay, so I hope you get that. You follow? Okay. So we are now on the step 3. So in step 3, add the results obtained in step 2. So recall that we multiply the value of x by its corresponding probability. So by doing that, we get 1/6, 2/6, 3/6, 4/6. So again, 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. So these are the results we got upon multiplying x by p of x. So in step 3, just add these results. So we have here 1/6 plus 2/6 plus 3/6 plus 4/6. Sorry, uh, 4/6 plus 5/6. Sorry, again, 5/6 and 6/6. So notice that they are like fractions. So recall that when multiplying like fractions, you simply add the numerator and copy the denominator. So by doing that, we have 21/6. 21/6 is also, or 21/6 also means 21 divided by 6. So we get 3 and 5/10. So as a result, so we have here the summation. Why we have here the summation? Because we add the results in step 2. So recall the lesson you have discussed in statistics during your junior high school days. So we have here the summation of x times p of x is equal to 3/5. So this is already our mean, the mean of a discrete random variable. So what does this mean? What does 3.5 or 3 and 5/10 mean? So if you roll a die many times, the theoretical mean, the number of spots that would appear is 3 and 5/10. So this is not exactly the number of spots that would appear because in your die we do not have 3.3 and 5/10 as the number of spots. So this is just a theoretical mean. So if you roll a die many times, would appear the number of spots that would appear is 3 and 5/10, which is our mean. So I hope you get that, you get the point. So you can still replay this part if you do not get the point. Um, you can replay backward and pause and play. Okay, so let's proceed to the next example. Our example 2 is Oswag Community Kitchen. So are you familiar with this? During the ECQ, the community kitchen of the Iloilo City has started during the enhanced community quarantine. So we have here example number 2, Swag Community Kitchen. So the city mayor initiated the community kitchen on March 22, 2020 when the city was placed under enhanced community quarantine. The community kitchen is a program wherein the parent leaders, daycare workers, and SF workers prepared meals to be delivered to the people in the community. So this is an example. The picture shows the helpers or the leaders, the parent leaders, helping each other preparing meals to be delivered to the community, the people of the community. So this is what we call the Iswag Community Kitchen. Now, what is the problem? So the table below shows the probability distribution. We're going to find the mean of the probability distribution. So again, recall the steps in finding the mean of the probability distribution. Okay, so the first step, again, construct the probability distribution for the random variable x representing the number that would appear. So our random variable here is the number of food packs. So we still use x as the random variable. And we have the probability distribution of p of x. So if you recall, we just construct a table of probability distribution. So this is already given in the problem. So we have here the number of food packs, x and p of x. So we have here 40, 45, 50, 55, and 60. So the probability of 40 is 2600s. For 45, we have 2400s. For 50, 1800s. For 55, 2200s. For 60, 1000s. So if you add these probabilities, you will get 1. The sum is 1. And if you have noticed, their values are greater than 0 but less than 1. So this is exactly a probability distribution. So that is our step 1. Step 2. What is our step 2? Okay, so multiply the value of the random variable x by the corresponding probability. So again, our equation here is x times p of x. Simply multiply the value of x to its corresponding probability. Example, 40 times 2600s, we get 10 and 40 hundredths. So again, you multiply the x by its corresponding probability. So you do not multiply, don't multiply x to the probability to, what do you call this? Do not multiply x when it is not its probability. Example, you multiply 40 by 24 hundredths, which is not its probability. 24 hundredths is the probability of 45. So you just multiply its corresponding probability. So I hope you get that. Another one, 45 times 24 hundredths, we have 10 and 80 hundredths. 50 times 18 hundredths, we have here 9. 55 times 22 hundredths is equal to 12 and 10 hundredths. And 60 times 10 hundredths, we have here 6. Okay, next, ours. So step 3. We are again on step 3. Add the results obtained in step 2. So recall, in step 2, we have here the results when we multiply x by its probability or p of x. So we have the results, we have the values from 10 and 40 hundredths down to 6. So we simply add these results or these values. So by doing so, we have 10 and 40 hundredths plus 10 and 80 hundredths plus 9 plus 12 and 10 hundredths plus 6. The sum is equal to 48 and 30 hundredths. So by that, we have here the equation. Since we add the results obtained in step 2 by multiplying x times p of x, we have here the summation. Summation of x times p of x is equal to 48 and 30 hundredths. So this is already the mean of our random variable, which is the number of food packs. So what does it mean? Does the Uswag Community Kitchen exactly delivers 48 and 30 hundredths number of food packs? So the answer is no. Why? Because there is no number of food packs as 48 and 30 hundredths. Because we can have 48 counted as whole numbers. We can have 48 food packs, but we do not have 30 hundredths. We do not have 30 hundredths food packs. How do you count that food pack as 30 hundredths? So this is just a theoretical mean. What does it mean again? Because we have here different data sets from 40, 45, 50, 55, 60. So we are doing average. We are averaging. So notice that when we get the average, we can have the value is not always whole numbers. We get we might get a portion of a whole number, or we get decimal points because we are averaging. So again, these values, the 40, 45, 50, 55, and 60, are closer to 48. The representation is 48 and 30 hundredths. So again, so for doing those exercises, or for having those exercises, we have here the formula. So again, we have here mu, the mean of a random variable with discrete probability distribution is mu. This is read as mu, a Greek letter. So mu is for mean, the symbol for mean. So is equal to x sub 1 times p of x sub 1 plus x sub 2 times p of x sub 2 plus x sub 3, so on and so forth. So you simply add these results. So you have here the formula to get the mean of probability distribution is equal to mean, mu, is equal to the summation of x times p of x. So you have here the legends. Okay? So let's proceed to another topic which you need to learn, which is all about measures of spread of the random variable. When we say spread, it talks about the coverage or the extent or the distribution of something. So we have two measures of spread or dispersion of the random variable. We have the variance and standard deviation. When we say variance, it measures the measure of how spread out a data set is. Example, our data set is the COVID-19. So how spread out how spread out a, a virus or the COVID-19 is. So just relate that to that situation. So how spread out. So maybe we can answer that it's worldwide. It's too wide. The coverage is too wide because it is already worldwide. So again, the variance measure of how spread out a data set is. If it's too wide or too narrow. Another one is standard deviation. So it measures the spread around the mean. So it is just its concern is just the mean. Example, if we have the mean of 48 and 30 hundredths and we have a data of 45. So how spread is 45 from the mean, or what is the distance, or what is the coverage, or what is the distance of 45 from the mean. So it is just when we say standard deviation, it talks about, or it is concerned with the mean. So how to compute the variance and standard deviation of the discrete probability distribution? So we have here the example. It is already example number 3. COVID-19 infected persons in a barangay. So we have here the situation. This is it is also found in your learning activity sheets. The number of persons infected per day in a barangay, along with its corresponding probabilities, is shown in the following table. Compute the variance and the standard deviation of the probability distribution. So we need to calculate the variance and the standard deviation. So what is the random variable here? So if you've noticed, a random variable here is the number of persons infected per day. So the number of persons infected per day. So next. So we have here the solution. This is already given. We have here the given data set. It is already in a table. We have here the number of persons infected as our random variable x. And we have here the probability r, p of x. So we have here the number of persons infected 0. The probability is 1/5. We have here 1. Probability is 3/10. We have here 2. Probability is 1/10. 3. Probability is 1/10. 4. The probability is 1/5. And 5. The probability is 1/10. Okay, so that is already given. So we proceed to the solution. First, in getting the variance in standard deviation, here is the first step. You just follow this one. First, we're going to find the mean of the probability distribution using the formula. So, you need to use your knowledge gained from our previous discussion. So, finding the mean. Of course, you already know that the process. We multiply x times p of x and add the results, then we get the mean. So by doing that, so again as a review, here how do we get 0? We multiply 0 by 1/5, 1 times 3/10, 2 times 1/10, 3 times 3 times 1/10, 4 times 1/5, and 5 times 1/10. Then we add the results. We add the results and we got the mean. The summation of x times p of x is 21/10, or 21 divided by 10 is, we have 2 and 1/10. So this is our mean. Take note of that. So that would mean the number of infected persons in a barangay would likely to appear as 2 and 1/10. This is just a theoretical mean. So that's the mean. So that is already our step 1. Next, our step 2. Subtract the mean from each value of the random variable x. So subtract the mean. So again, we create a table. The first column here is our x. So take note that we have here the values of x. Next, make another column for the mean. That's mu. So recall that our mean is 2 and 1/10. So it's uniform all throughout. Next is the process. We proceed here. Subtract the mean from each value of the random variable. So we have here the random variable x. So here, and minus the mean or mu. So we have here 0 as x, the value of our random variable. So 0 minus the mean, 2 and 1/10, is equal to negative 2 and 1/10. So why negative? Because we have here smaller value, it is bigger value. So we get negative value. So 0 minus 2 and 1/10 is negative 2 and 1/10. So next, 1. 1 is our x. So 1 minus the mean is equal to negative 1 and 1/10. So again, negative because 1 is less than 2 and 1/10. So negative. Next, our value here, our x here is 2. So 2 minus 2 and 1/10 is equal to negative 1/10. Because, why negative? Because 2 is less than 2 and 1/10. Next, our x here is 3. So 3 minus 2 and 1/10 is equal to 9/10. Next is 4. So 4 minus 2 and 1/10 is equal to 1 and 9/10. So it's already positive because 4 is greater than 2 and 1/10. Next, the last is 5. So we have here 5 minus 2 and 1/10 is 2 and 9/10. So simple as that. That is our step 2. Next, step 3. We have to square the results obtained in step 2. So we have here our step 2. So these are the results. These are the results of we obtained in step 2. So we have negative 2 and 1/10, negative 1 and 1, negative 1 and 1/10, negative 0 and 1/10, 9/10, 1 and 9/10, 9/10. Against 9/10, 1 and 9/10, 2 and 9/10. So these are the results. What are we going to do with the results obtained in step 2? We're going to get to square the results. So when we square, we simply multiply itself twice, by itself twice. So how? So example, if our first result obtained is negative 2 and 1/10, it means that we simply square 2 and 1, sorry, 2 and 1/10 square. So it is equal to 4 and 41/100. What the square means? It is simply multiplying by itself twice. So meaning negative 2.1 times negative 2.1, and we will get, and the product is positive 4 and 41/100. hundredths. Why positive? Because negative times negative is positive. So 2, negative 2 and 1/10 times 2, negative 2 and 1/10 is equal to 4 and 41 hundredths. Next is negative 1 and 100. So it means that we multiply negative 1 and 1/10 by itself twice. So that we will get the result 1 and 21 hundredths. So how? So we have here example how it how to do that. So negative 1 and 1/10 times negative 1 and 1/10, that would give us positive 1 and 21 hundredths. So again, negative times negative is positive. Next, negative 0 and 1/10. So this is negative 0.0 and 1/10 squared. So you simply follow this step. So negative 0 and 1/10 times negative 0 and 1/10 is equal to 0 and 100ths. Next, the same thing. 9 tenths times 9 tenths is, or 9 squared. 9 tenths squared is equal to 81 hundredths. The same thing. 1 and 9 tenths times 1 and 9 tenths is equal to 3 and 61 hundredths. 2 and 9 tenths squared is equal to 8 and 41 hundredths. So you simply multiply. So it's the same procedure. 2 and 9 tenths times 2 and 9 tenths is equal to 8 and 41 hundredths. So that would give you this one. So simple as that. That is our step 3. So that means quantity of x minus mu squared. Okay, step 4. In step 4, simply multiply the results obtained in step 3 by its corresponding probability. So recall that we have here the given x and its corresponding probability. So the results obtained in step 3 are given here. So these are the results obtained in step 3 from here. So these are the results obtained in step 3. So what shall we do with these results? So according to the process, to the procedure, multiply them one by one by the corresponding probability, or the P of x. So the P of x is here. So how can we do that? Example, the first result for we will use yellow for it to become visible. Example, the first result is 4 and 41 hundredths. We will multiply this by the corresponding probability, which is 1/5. So times 1/5. So that would give us 4 and, so we have your imaginary denominator 1, because that would also, this is just the same. Numerator by numerator, denominator by denominator. So it is easy for you to understand. So 4 and 41 hundredths times 1 that is 4 and this is decimal point. 4 and 41 hundredths. 4 and 41 hundredths. 1 times 5 is also 5. It's equal to 5. So 4 and 41 hundredths divided by 5. So better to get your calculator or your cell phones or simply do it manually. So divide 4 by 4 and 41 hundredths divided by 5. So you will get 882 thousandths because we have 3 decimal points. 882 thousandths. So it is displayed here. Next, another one. Let's have another example. One and another example. 1 and 21 hundredths. So 1 and 21 hundredths multiplied to 3 tenths. So just the same. We place it here. Example. 1 and 21 hundredths times its corresponding probability, which is 3 tenths, times 3 tenths. So multiply the numerator. 1 times 1 and 21 hundredths times 3. So get your calculator or simply do it manually. 1 and 21 hundredths times 3, you will get 3 and 63 hundredths divided by 10, because we simply copy this 10 because we have here 1. So divide it. 3 divided by 10, we get 363, that's 363 thousandths. So that 363 thousandths is written here. It's just the same with the the remaining. So you multiply 100 to 1/10 and you will get 1,000. Multiply 81 hundredths by 1/10 and you will get 81 thousandths. Multiply 3 and 61 hundredths by 1/5, you will get 722 10,000ths. Multiply 8 and 41 hundredths by 1/10 and you will get 841 thousandths. So that is how you determine step 4. I hope you get the process. Next, we proceed to step 5. So in step 5, get the sum of the results obtained in step 4. The results is already the value of variance. So, by the way, the equation that we used in step 4 is this. So this is the result obtained in step 3 times the corresponding probability. So this is the equation we use in step 4. So to follow the step 5, simply add the results. So these are the results obtained in step 4. So we simply get the sum or we simply add these results. By adding, if you try to do it in calculator or in manually, you will get 2 and 89 hundredths, which is already the value of our variance. So we can conclude that the value of variance, the symbol is this. This is a Greek symbol. So this is the symbol for variance. So this is sigma squared. This symbol is called what we call sigma. So sigma squared is our variance. It's equal to the summation, since we add the results, summation of quantity of x minus mu squared times its corresponding probability. That would give us 2 and 89 hundredths. So this is the variance. So take note of the formula. How about the standard deviation? So to get the standard deviation, just get the square root. This is our step 6, which is the process on how to get the standard deviation. So just get the square root of the variance. So the variance of the probability distribution is 2 and 89 hundredths. So simply get the square root of 2 and 89 hundredths. That would give us 1 and 70 hundredths. So the symbol for standard deviation is sigma. So just get, so we can have the formula, square root of the variance. Simple as that. So those are the steps in getting the variance of our discrete random variable. So if it's too fast for you, you can review, you can play backward and recall the steps. Anyway, you have this copy on your learning activity sheet. So just follow the process. So again, the number of infected persons per barangay in the barangay with a mean of 2 and 1/10 has a variance of 2 and 8900. So this is how spread the data set is. So the spread is 2 and 8900. So this is a theoretical variance. Next, the standard deviation, how spread the data is around the mean. If our the mean is 2.1, if the mean is 2.1, the data set, the standard deviation or the spread of the data set around the mean is equal to 1 and 70 hundredths. Okay, so that is the standard deviation. So by doing those activities, we have here the formula. We can summarize the formula for the variance and standard deviation of a discrete random variable as this. So for the variance, we have here sigma squared is equal to the summation of quantity x minus mu squared times p of x. For the standard deviation, just get the square root of the variance. So the symbol for standard deviation is sigma. So we have here the legends. The x is the random variable, the p of x is the probability, and mu is the mean. So we also have the alternative formula to find the variance and standard deviation. So if you find this easy, you can use this formula. Anyways, you will still arrive at the same answer. So for the alternative formula, we have here the step 1. They are the same. Find the mean. The mean is still 2.2 and 1/10. So that is the first step for our alternative formula. Next, multiply the square of the value of random variable x by its corresponding probability. So we have here the formula x squared times p of x. So meaning, you have to get the square first of x before multiplying it by its corresponding probability. Example, if we have 0, so we get the square of 0. So 0 squared is 0 times 1/5 is 0. 1 squared is 1 times 3/10 is equal to 3/10. 2 squared 2 squared is 4 because 2 times 2 is 4 times 4/10 is equal to 4/10. 3 squared is equal to 9. 3 times 3 is 9. And 9 times 1/10 is equal to 9/10. 4 squared is 4 times 4 is equal to 16. And 16 times 1/5. 1/5 is also equal to, comes from 2/10. For us to add the results, for us to have common denominators of 10, we can use 2/10. It's just the same as 1/5. So 2/10, 16 times 2/10, you will get 32/10. If you try to multiply 16 by 1/5, so you will get 16/5. 16/5 is also equal to 32/10. So we will use 32/10 for us to have a common denominator of 10. For us to uh, for us to have an easy summation later. 5 squared is equal to 25. And 25 times 1/10 is equal to 25/10. So that is how we multiply to its corresponding probability. So this is the step 2 of the alternative formula. The step 3 in our alternative formula, as what I am saying a while ago, we shall add the results obtained in step 2. So here are the results, and we simply add these results to get the sum. So as we get the sum, so we have here the formula summation of x squared times p of x is equal to 73/10, or 73 divided by 10 is 7 and 3/10. So step 4, for the alternative formula, you're going to subtract the square of the mean from the results obtained in step 3 to get the variance. So our variance is sigma squared, that is equal to summation. This is the result obtained in step 3. So we subtract the square of the mean from the results obtained in step 3 to get the variance. So if you have recalled last time, the result of summation of x squared times p of x is 7 and 3/10. Minus, we get the square of the mean. Our mean is 2 and 1/10. So you're going to get the square. Means 2 and 1/10 times 2 and 1/10. So 2 and 1/10 squared is equal to 4 and 41/100. So 7 and 3/10 minus 4 and 41/100 is equal to 2 and 89/100, which is the value of our variance. So in this formula, the alternative formula, the formula for to get the variance is summation of x squared times p of x minus mu squared. So the standard deviation, to get the standard deviation, just get the square root of the variance. Still the same. So just get the square root of the variance, which is 1 in 70 hundredths. So simple as that. It only has 4 steps to follow. Unlike the first one, you will have to go through 5 steps, I guess. So it's up to you whether you use this alternative formula or the first one that was presented to you. So either way which you feel comfortable with, you will still arrive at the same answer. Okay, so I guess we are now on the activity proper. So I hope, by the way, you in getting the variance and the standard deviation, just go back to the procedure and recall the steps. Anyway, you have there with you your learning activity sheets. So our activity proper. So again, we always follow the general directions in our LAS. So it is found in your activity sheets. Exercise 1, exercise 2, and the guide questions. I also provided you with the supplemental learning activities for you to practice your skills. So you have to answer those supplemental activities a for you to be able to practice the skill that you have. You also have here the exercise 3. For the reflection part, this will be written in your journal. So don't forget to write your reflection in your journal. I have also provided you with the supplemental learning activity sheets wherein you can practice your skill. Please do not forget to answer those activity sheets because I will be going to check that. And please do not forget to write your comments, your feedbacks, your suggestions about this video lesson. If you have something to say about the video lesson, if you have something to suggest for the improvement, or if you have something that you do not like or you find it difficult for you, just write it on a piece of paper, and you can write anything. You can write it in either in Tagalog, Hiligaynon, or in English. Just do not write the unrelated topics. Okay? So thank you for listening. Hope you have learned something from this lesson.